Coffee. It's a universal wake-up call and a cultural staple that transcends borders. Whether you're grabbing a quick morning cup, meeting friends at a cafe, or pulling an all-nighter, coffee has become an essential part of everyday life. What might surprise you is that instant coffee, often seen as a quicker solution, originated all the way back in 1890. Over the years, technological advances have pushed instant coffee from being a mere novelty to a worldwide phenomenon. Leading this transformation is Nestlé's Nescafé, a brand responsible for fueling a staggering 1 billion cups of coffee every single day. Have you ever wondered how such a monumental supply chain actually works? Today, on Infinite Farming, we'll take you on a revealing journey through Nescafé's production process. From the delicate coffee flowers that bloom on tropical farms to the high-tech freeze-drying chambers that deliver those crave-worthy granules directly to your mug, the scale and sophistication behind your everyday cup of Nescafé might just change the way you think about instant coffee forever. When we talk about Nestlé's Nescafé, we're talking about one of the most recognized coffee brands on the planet. It isn't merely a success story. It's a colossal operation that supports millions of coffee drinkers across continents. Every day, Nescafé caters to around 1 billion cups worldwide, a number that's still growing as coffee consumption remains on the rise, especially in developing markets. To maintain this extensive reach, Nestlé collaborates with over 100,000 farmers spanning key coffee-producing regions such as Brazil, Vietnam, Colombia, and more. This diverse sourcing approach not only secures a consistent supply of beans, but also helps the brand balance flavor profiles to suit different consumer preferences. In fact, each region contributes its own unique qualities to the blend. Brazilian beans often lend nutty, chocolatey notes, while Vietnamese varieties can bring a robust, full-bodied character. All of these beans funnel into 24 state-of-the-art factories, each strategically located to reduce shipping times and production costs. Collectively, these factories process close to 13 million bags of coffee beans annually, adhering to rigorous quality standards that ensure a uniform taste in every jar. Balancing that massive volume with consistent quality is a testament to the precise coordination that makes Nescafé a household name. It all starts on lush plantations, often perched on high-altitude slopes, where the climate is just right. Many regions favored by Nescafé, particularly in Brazil, feature rolling hills that stretch as far as the eye can see, dotted with row upon row of coffee plants. Meanwhile, Vietnam has become a powerhouse in its own right, largely focusing on Robusta beans, known for their stronger, more caffeinated kick. Before the cherries appear, the coffee plants undergo a fleeting but beautiful phase of white blossoms, which can blanket entire fields in a matter of days. These delicate flowers quickly give way to tiny green cherries, which ripen over the course of 6 to 9 months. By the end of this development cycle, they turn a vibrant red, signaling the perfect moment for harvest. Harvest timing is a delicate art. If farmers wait too long, cherries can over-ripen or fall to the ground, while picking too early results in beans that haven't fully developed their flavors. The goal is to harvest when about 95% of the cherries have turned red, leaving only a small fraction still in the greenish phase. This balance ensures that the beans deliver the signature taste that Nescafé customers expect. While hand-picking remains a tradition in many smaller farms, especially those focusing on specialty-grade coffee, the enormous quantities required by Nescafé demand more automated solutions. Large-scale plantations often employ specialized mechanical harvesters that roll through rows of coffee trees, using carefully calibrated vibrations to dislodge ripe cherries with minimal damage to the plants. These harvesters can be outfitted with as many as 1,500 vibrating rods, each capable of shaking branches up to 1,000 times per minute. The rods are set to a frequency that effectively removes cherries that have reached the right ripeness, leaving behind those that remain unripe. Beneath these rods, collector plates catch the falling cherries and channel them onto conveyor belts, which deposit them into large hoppers. The efficiency is remarkable. A single machine can collect as many as 60 bags of cherries in a 5-hour window, vastly reducing the need for manual labor. Mechanization also helps address labor shortages in remote farming regions, where finding enough pickers during peak harvest can be challenging. Critics once worried that heavy machinery might damage the soil or unripe cherries, but innovations in design have mitigated these concerns. Modern harvesters operate with surprising delicacy, ensuring that farms can scale up while maintaining sustainable practices. Once harvested, the cherries must be processed as swiftly as possible, ideally within 8 to 12 hours, to maintain flavor and aroma. This timeline is critical because any delay could compromise quality or lead to spoilage. The first major step after harvest happens at what's known as the wet mill. At the wet mill, the cherries are emptied into large, water-filled tanks. Ripe cherries, being denser, sink to the bottom, while the less ripe ones float and are skimmed off. This simple but effective method sorts out subpar cherries early. From there, the ripe cherries pass through rotating drums with a textured interior, which apply just enough pressure to remove the outer pulp and skin without crushing the beans. After depulping, each bean is still enveloped in a sticky layer called mucilage. To strip it away, farmers move the beans into fermentation tanks. Over the next 12 to 24 hours, enzymes break down the mucilage in a controlled environment, leaving the beans clean and ready for the next phase. Too much fermentation can ruin the beans' delicate flavor, so workers periodically check the beans to ensure the process doesn't overshoot its mark. With fermentation complete, the beans need a thorough washing to remove every trace of mucilage. Fresh water is added to the tanks, and farm workers use wooden paddles or mechanical stirrers to agitate the beans until the water runs clear. Achieving a clean, parchment-layered bean at this stage is crucial for flavor consistency, because even tiny residues can lead to off-notes when roasted. Once washed, the beans head to the drying phase. Traditionally, they're spread out on large patios or raised drying beds, where they soak up the sun's warmth and natural breeze. Farmers or workers use rakes to turn the beans at regular intervals, allowing uniform drying. In regions prone to unexpected rain or humidity spikes, mechanical dryers may supplement or replace sun drying to ensure a stable drying environment. The target is about 11% moisture. Anything higher risks mold, while anything too low can degrade the beans' essential oils and overall taste. Finally, there's the hulling stage. Here, the dry parchment skin that surrounds each bean is stripped away. These green beans, now ready for transport, are packed into 60-kilogram jute, or synthetic sacks. Labels indicating origin, grade, and date help maintain traceability, a crucial part of Nestlé's quality assurance protocols. The journey continues when trucks carrying these sacks of green beans arrive at Nestlé's advanced processing facilities. Robotic arms fitted with spider-like grippers lift each sack, placing it onto conveyor systems. This not only speeds up unloading, but also significantly reduces workplace injuries related to heavy lifting. As sacks progress through the facility, moisture sensors scan each one to confirm it meets the factory's strict parameters. Some sacks are randomly selected for probing, where a robotic mechanism extracts a small sample of beans to evaluate flavor, aroma, and appearance. The extracted samples then move on to human tasters, known in the industry as cuppers. Even with the growth of artificial intelligence and quality control, these expert tasters remain the final gatekeepers, detecting subtle notes that might hint at fermentation issues or other flaws. Because Nestlé operates across multiple continents, these practices can differ slightly from one factory to another. However, the principle remains the same. Combine cutting-edge automation with the nuanced skill of human experts to ensure that every bag of beans aligns with Nescafe's reputation for reliability and flavor consistency. Roasting is where the coffee bean's potential is truly unleashed, revealing the complex aromas and flavors we associate with a great cup. Green beans arrive at industrial roasting drums capable of reaching temperatures between 370 degrees Fahrenheit and 540 degrees Fahrenheit, 188 degrees Celsius to 282 degrees Celsius. Inside these drums, specialized paddles constantly move the beans, preventing scorching on any single spot. Roast profiles can vary depending on the end product. Lighter roasts, taking around 8 to 10 minutes, emphasize brighter flavors and often retain more acidity and caffeine. Medium roasts strike a balance, showcasing deeper caramel and chocolate notes while still maintaining some lively brightness. Darker roasts, sometimes stretching up to 15 or even 20 minutes, develop a smoky richness and slightly lower caffeine content. The choice of roast depends heavily on what flavor profile Nestlé is aiming for in each specific Nescafé blend. Upon reaching their target roast level, the beans tumble into cooling trays, where powerful fans blow to reduce their temperature quickly. This immediate cooling step prevents the beans from continuing to coast in temperature, locking in the desired flavor compounds. Many factories also include additional sensors that monitor everything from bean color to surface temperature, providing real-time data that roasters can use to fine-tune every batch. After roasting, certain beans are earmarked for Nescafé instant coffee. This involves grinding the beans into a coarse powder, then brewing them into a thick, highly concentrated coffee extract. Two main production methods transform this extract into the convenient crystals or granules found on store shelves everywhere: spray drying and freeze drying. In spray drying, the hot coffee extract is sprayed into a tall chamber where it's met by extremely hot air, often around 1,000 degrees Fahrenheit. The intense heat rapidly evaporates the water from the tiny droplets of coffee, leaving behind fine coffee particles that settle at the bottom. This process is renowned for its speed and cost-effectiveness, making it the go-to method for classic instant blends like Nescafé Original. Freeze drying, on the other hand, is a more complex and meticulous process aimed at preserving intricate flavor nuances. First, the coffee extract is thickened into a syrup-like consistency. It's then chilled in a sub-zero environment, commonly around -58 degrees Fahrenheit, forming sheets of coffee ice. Rotating blades break these sheets into small shards, which enter a low-pressure chamber at roughly 140 degrees Fahrenheit. Here, the ice sublimates directly from a solid state to vapor, bypassing the liquid phase entirely. Known as sublimation, this gentle process better retains the coffee's natural aromatics, resulting in premium products like Nescafé Gold. Although it's more expensive and time-consuming, freeze drying is favored for blends where taste complexity is paramount. Once the drying phase is complete, be it via spray or freeze drying, the coffee is ready for packaging. High-speed conveyor systems feed the granules into glass jars or other sealed containers at astonishing rates, sometimes 320 jars per minute or more. Each jar is flushed with an inert gas or vacuum sealed to eliminate as much oxygen as possible, maximizing shelf life and preserving freshness. Labels are then applied, detailing everything from roast intensity and flavor descriptions to nutritional information. Quality control checkpoints at this stage include weight checks, cap tightness inspections, and even camera-based label alignment to ensure each product looks as consistent as it tastes. Shipped to regional distribution centers, these jars make their way to supermarket shelves, online retailers, and restaurant supply chains. The incredible efficiency of the system means that within days or weeks of leaving the farm, your morning cup of coffee could be sitting comfortably in your local store, waiting to deliver that bold burst of flavor the moment you pour hot water over it. From the bloom of tiny white flowers to the freeze-dried crystals waiting in your pantry, the story of Nestlé's Nescafé is one of advanced technology, meticulous craftsmanship, and continuous innovation. Every sip you take represents a chain of farmers, factory workers, robotic arms, and taste experts, all working together to guarantee the comforting taste of instant coffee we've come to rely on. What does the future hold for coffee production on such a global scale? With new challenges like climate change, shifting consumer tastes, and rapid population growth, companies like Nestlé are investing heavily in research on drought-resistant coffee varieties, precision farming, and eco-friendly packaging solutions. At the same time, AI and robotics continue to play a larger role, raising the question, might we one day see fully automated coffee plantations, or will the human element remain an irreplaceable piece of the puzzle? We'd love to hear your perspective. Do you think technology will ultimately overshadow traditional farming techniques, or does genuine human intuition still have the upper hand? Share your thoughts in the comments below, and let us know whether you believe coffee's future lies in cutting-edge automation or a balanced partnership between man and machine. If you enjoyed this in-depth exploration, be sure to like this video and subscribe to Infinite Farming. We'll continue unearthing the fascinating stories behind the foods we love and the groundbreaking methods that bring them to our tables.